Hey there, everybody. I am in, let's see, we are in modules. I'm in the module 3. We're going to take a look at singly linked list. So, and for now, let's just copy and paste this whole code. We don't need this top part, but we're going to come back and look at it later and enact it. Oh, I know what I was going to do, and I didn't get done. Carlos distracted me.
I'm sorry.
It's not your fault. I let you. I need to get my video camera up running. Because this is very much a pictorial thing. All right. And we'll fix the resolution so it comes in crisper. Move the camera to the side. And bring that to the front. Okay. So we are doing singly linked lists. And looking at the picture kind of shows what happens. Each thing we have, it's dealt with by pointers. And each thing we have has a point to the object, and the object has a pointer attached to it. So we're going to make a class that has, like in this case, a string object and a pointer stored in it. And we build this list by just jumping along until we get to the end, which will be a null pointer. So if you've copied and pasted that in, we can come over here and take a look at it. We tend to call these nodes. This is much like a train car. You're making a connection of train cars. So we did notice we have our item. It's going to be just string. And then rather than doing node, we're going to, if we looked at the picture, it's a pointer. The second item is actually a pointer to the next spot. So that's what our other thing is. And we're going to do a pointer to the next node. This class is actually calling, part of it is a pointer to another node, which is kind of cool. It's calling almost self-referential, but it's not referring to itself, just referring to something that just like it. We have 3 different constructors we'll go take a look at. We've got get and set for our accessor methods, and we have a node next pointer. Let's come and take a look at what's going on in the code. Let's go look at the constructors.
And by the way, where is page 7? Because I was looking at one thing, so I can't find it.
What?
The copy and paste.
It says singly linked lists. It's in module 3. So come over to module 3, grab it, copy and paste, because we're going to edit it. We're going to do all sorts of shit. It's that one right there. But quit rolling. That one right there. Go in it, there's code, grab it. That's what we're adapting. So the default one where it doesn't take anything, it's just going to set the string to a blank. And it's got the next pointer set to null pointer. We want to make sure we do this every time. Where we create something, it's going to have a null pointer. The one where we take in a string argument allows us to just put in, this is probably the most common one to use, because that's the one you really care about. You don't know where the next node is going to be in memory. So there's no reason to set next pointer in it. But if you happen to be doing, like later on when we're doing doubly linked lists, and when we're tinkering with this, this might be a great one to have where we can actually tell it what pointer to use, because we might try to insert it in the middle, like to have a train with all the cars, decouple a couple with train cars, and put a train car in the middle. And how do you hook all that up? Well, this one might help us later on, but that's not even today, probably not on Wednesday. We got a couple set and get. Set the item, return the item, set the pointer, return the pointer. All right, let's come take a look at that code in the main. And let's see what it's doing. Let's bring up the camera and have it running simultaneously while I do it. So what we're gonna have, let's see if I can do this well. Might be easier to have it like that. How far down does it go? That doesn't get most of the page. So let's go sideways. That doesn't get most of the page either. So fuck it, we're doing it like that. So I'm gonna have I'm gonna make a pointer called head pointer. And right now I'm just gonna say put null up here. Null PTR. And we're gonna start off with head pointer pointing null. So that's line 34. And then we build another node. We're gonna say, we're gonna create a node here. A node has an object and a pointer. And right now, nothing's being populated to it. So this initially gets set to empty. And this initially starts off pointing to the null pointer. If we go down and we can double check that. This is doing set next pointer to our null pointer. And set next pointer, what is that doing? It's setting next pointer to our argument pointer. So it's taking null pointer and saying next pointer. Remember, we only have two things. We have an item and we have the next pointer. That's on every node. What's your question, Carlos?
Oh, no, okay. I did have a question, but I didn't, okay, so what I'm saying is, we have like the original plan, right? And so we're pointing towards to next item, which is a null point. But doesn't null point mean that it has nothing in it?
It has nothing in it. It's pointing to nothing. You always want to start off having it point to nothing. That way, if someone happens to access it before you do something, it is not randomly pointing to some element in your memory and giving you junk. So null pointer is going to make it so it's doing that. Oop, I wanted to back up. So then we come up here and we made this node here. This one was called my node. That was line 35. And then we're going to make another node called current pointer. I'm going to put it over here. Cur node PTR. And it's also pointing to here. And that's at line 37 right now. So now we're going to do what's called hard coding a singly linked list. After we go through the hard coding so you understand how it's working, we'll come up with a way to speed this up where you don't have to type up every line, but you kind of need to know how this works. Like you really need to know how this works because it's going to be harder on doubly linked lists. And there may be an element on your test where it's going to be like write up a short segment on how this is doing. Not on a computer, but like on the written portion. So we come down here, line 42 says current node pointer is going to point to a new node called Mary. So when we make a new node with just the string, what goes on there before I make my box? The new node sets the item to the argument and it sets the next pointer to null pointer. So what we're going to do, where is it? Line 42, what it does is it makes a box here somewhere else in memory. It populates this to Mary. And this is pointed at null pointer. And this thing doesn't have a name. It's just the new node. This one had my node attached to it, but this one's just blank. This happened at line 42. And also part of line 42 is current node pointing to it, which means that kills the connection there. So now head pointer's pointed to null, current pointer's pointed to Mary, nothing's pointed at my node. And we go on to 43. 43 says head pointer equals current node pointer. And current node pointer is pointing to this. So line 43 says kill that connection. And now nothing's pointing to null pointer right now, except the Mary node and the my node. All right. Line 46. Ooh, my box is in the way. It says new node Bill. So set next pointer, new node Bill. So current node pointer says we're going to make a new node. Line 46, we're going to make a new node. This box is going to be called Bill. That automatically creates a null pointer there.
How do we know is it because the current pointer is originally a null pointer, meaning that the new pointer is going in?
Wait, what?
I mean, it is annoying.
Okay, good.
I'm sorry.
I actually said that wrong. That is not what 46 did. 46 did make it, but it said 46 takes current node pointer, which is this one. 46 says do this. Kill the green connection. So this was killed in line 46. And it says set next pointer from current node. Current node is here. So current node's next pointer is going to point to Bill. Actually, I should say to Bill. Points to Bill. And that was at line 46. Line 47 says current node pointer equals current node pointer get next pointer. So get next pointer goes and retrieves what's next. So current node is currently pointing there. Get next pointer says that one, because that's the next pointer in line. Well, it says kind of like that one. And the thing on the right says we're going to make current node pointer point to that. So we're going to, it's kind of like doing vector redirection. We're going to redirect from Mary to Bill. Current node pointer, we're going to kill this connection right here. And line 47 says we're going to point there. So line 47 right now, my node's still doing fucking nothing. I don't even know why it's in there. Mary is, head pointer is pointing to Mary. Mary is pointing to Bill, and current node's pointing to Bill. Then we go on to line 50. Current node next pointer is going to be new node James. Current node, this is current node. Its next pointer should point to a new node called James. When we do that, James gets set to null pointer. The pointer to the old null pointer from the end of Bill is gone. So right now, what we've kind of got pictorially, head PTR is pointing to Mary, and Mary is pointing to Bill, and Bill is pointing to James, and James is pointing to null PTR. And current pointer, as of line 47, current pointer is pointing to Bill at line 47. No, line 50. We're at line 50 already. But then line 51 says, take this one, get its next pointer, so it's James. And where it says take current pointer, we're going to set current pointer equal to its next pointer, which is crazy. It's basically saying jump ahead one car. So line 51 says kill that connection and make the connection there. So kind of we got this train here. This is a little getting a little messy here, isn't it? And fourth node does the same thing, but with an Aubrey. So where is it? Line 54. Line 54 makes an Aubrey. It's also a box. And it says we're going to take next pointer from current node pointer, which is there. That one's destroyed. We're going to point it at current node pointer was pointed at James. Its next is going to point at Aubrey. Aubrey's next pointer is pointed back to null. And James's connection to null is gone. So down here with our short list, we're redirecting the train to follow Aubrey. And Aubrey is at null pointer. That happened at line 54. And line 55 kills the connection to James for current pointer and goes over to Aubrey. It's weird. You kind of need, this is like the current node pointer kind of thing is like a floater. We keep reassigning it. We kind of have to keep reassigning it. Otherwise, we have to start at head pointer because our node is only storing, we only have a couple of pieces of real information stored. We have where head pointer is stored. We know where that location is because that was a pre-existing node pointer. And so there's an address stored here in head pointer. There's an address stored in it. And that address is Mary's. But then if I want to get to anywhere later on the line and I started at head pointer, I got to keep going next pointer, next pointer, next pointer until I get to it. So the easiest way to keep adding onto the train is have something that points to the end of the train, which is what current node pointer does. Current node pointer points to the end of the train. Does that make sense so far? It's kind of tedious, right? Very tedious. We only made 4 of them. And it took I don't know, 20 lines of code there. Which means if we made 100 of them, it's going to take a lot more. And why would you make a linked list with only 4 elements? Why would you make anything with only 4 elements? If you're actually making a program and you're storing shit like that in there, it's like you're trying to build up basically a database, whether it's a little database or it's a big database. It's definitely, what's the database that stores 4? That's fucking nothing. That's the sad person's phone address, or the phones in their cell phone. There's only fucking 4 contacts. That's a sad person. Let's go ahead and give it a run, see what happens. We see line 57 is a pre-print string. So it looks like it prints the names of the people in order and throws out a couple lists empty. Let's figure out where that list empty comes from. Looks like this is all memory management. Print string, it must be in print string list. Let's go look at print string list. So print string list takes in a node pointer, and look at that. It's very descriptive. Whoever came up wrote this code, very descriptive, long name for an argument, but you know exactly what it is. This needs to be the pointer that starts it all. We're going to send temp node pointer. We're going to make a pointer for node. We're going to send it equal to that. And then if temp node is a null pointer, which means there's nothing in the list, head pointer is pointing to the null pointer. See out the list is empty. Otherwise, well, now what's going on here? Let's take a look at what's going on there. Yeah, but let's look what's going on with our list. So I'm gonna redraw it here. And we've got head pointer pointing to Mary. Mary's pointing to Bill. Bill is pointing to Aubrey. Nope, Bill is pointing to James. James is pointing to Aubrey. And Aubrey is pointing to null pointer. So the print list, it starts off, you always pass in the head pointer at the beginning of the list. So temp comes in and temp starts off, rather than saying temp node pointer, I'm just going to write temp. That way it takes up less writing. Temp comes in and temp says, we're going to immediately point to head pointer, which points to Mary. And now we get to that while list. And while temp node pointer, its next pointer does not equal null pointer, we're going to see out our current location, see out the current item. And then it says temp node pointer jumps to the next pointer. So like first loop of the while, it says, okay, it's not a null pointer. So temp node pointer's item, which is Mary, we're going to see out Mary. And then we're going to say temp equals the next node. Now temp's pointing at Bill. That's first loop. And it goes, we get to the bottom of the loop. It's temp node pointer's next pointer is not null pointer. The next pointer is at James, so it's not null pointer. So we're going to go through the loop again. It does a second loop. See out Bill. And temp is going to point to James. So that's second loop. We get to the bottom of the while loop. The while loop, the condition is the next node the null pointer? No, the next node is Aubrey. So we're going to run with it. So third loop. See out James. Temp goes to Aubrey. And we're at the bottom of the third loop, and we go back to the top and it says temp node's next pointer, is it the null pointer? Aubrey's next pointer is the null pointer. So the loop stops here. We have done a see out. We've seed out Mary. We've seed out Bill. We've seed out James. We have not done the final object. And that's where line 98 comes in. Line 98 says, let's do a see out of the final object. So finally, after while loop, see out Aubrey. So that's what's going on with the prints thing. You're going to see, we're going to do this whole thing of jumping to the next node. This is a common step we're going to want to use in a lot of what we do. Let's go back and see what else this code did. This code, then we got memory management. All right, what's going on with memory management? So it goes, okay, let's go back to our picture that we had here. This is where we left off. That's where we left off. Head's pointing to Mary, Mary's pointing to Bill, Bill's pointing to James, James is pointing to Aubrey. Aubrey's pointing to null pointer, and current node pointer is pointing to Aubrey. So line 60 says, okay, current node pointer, you're not going to point to Aubrey anymore. We're not building the train anymore. Line 60 redirects it to head pointer, which effectively directs it to Mary. Line 61 says head pointer is going to equal head pointer's next pointer. Head pointer is Mary, and Mary's next pointer is Bill. So line 61, that gets killed on line 61, and a new point goes over to that one. So head pointer is at Bill now. It looks like Mary's about to get the buckets. She's gonna get whacked. And because she's not the head anymore. Like there's a new boss in town. Line 62 says yes. Delete head pointer. Head or delete current node pointer. Current node pointer was pointing at Mary. Mary gets offed at line 62. Then we get to line 64. 64 redirects current node pointer. It was pointing at Mary, but now it's like kind of dead space. We're going to redirect current node pointer to Bill, because that's where head pointer is pointing. So now both of them are pointing at Bill. And this cycle kind of repeats. Head pointer gets to the next pointer to the next one on line 65. This was 64. And on line 66, Bill gets offed. And it goes down till we get to the bottom one. And let's see, how many have we done so far? So 65 killed Bill. Put James in charge. So the 68 through 70 is going to kill James. And 72 through 74 is going to kill Aubrey. So right now it says the last thing, 73 had set head pointer to null pointer. 73 sets head pointer to null pointer. I'm off screen. 73 sets head pointer to null pointer. And finally, line 76 sets current node pointer to null pointer. So everything's pointed at a null pointer, the 2 pointers that still exist. And apparently we never did anything with my node. It's fucking just dead to us.
I have a question.
Yes,
So how do you know which kernel we're talking about, even though we're from the start?
because we keep redirecting where current node is pointing to. It can only hold one piece of information. So when we give it a new pointer, like on line 64, current pointer was pointed at Mary, and it's still pointed at the address Mary was stored at. Current pointer was still stored pointing there. But at line 64, we said current pointer, we're going to point it at head pointer. Head pointer is pointing at Bill. And now the previous information is overwritten. It can only store one pointer. So that's why we even have that temp pointer, so that we can go through and do this building the train and deleting the train. This is tedious. This is tedious as hell.
That looks like,
That depends on all entirely on what you're trying to build. It's kind of helpful to know how this works for stuff we're going to be doing later, like maps and stuff like that. And knowing how it's built is like part of the course. That way you understand how this is, let's be honest, there are already fucking things in C++ that will do this shit fast for you. Okay. This class is learning on how shit works. So while you may not use this for very much, you could, if you wanted to, by the time we're done going through this whole linked list section, you could build your own stuff, but instead of using a pre-built command. The commands are used for stuff. building it on your own lets you know what's happening and it makes you more familiar with how memory management's working, how pointers work, how a lot of stuff works. So it's like, it's making you more of aware as a computer scientist rather than a long-term usage thing. What can I compare it to in mathematics? How often did you need to know the fucking hyperbola? The equation of a hyperbola. Never have. There are things that come up. The Gateway Arch in St. Louis is shaped like a hyperbola. The like hanging cables on like Golden Gate and shit like that have hyperbolic curves, trig functions for their shape. But like in general, you don't need them. But a lot of stuff is it's learning tool set and being better at, in that case, mathematics, in this case, programming, and understanding what's going on with programming. So this is learning how the hammer, like what the fucking, not the hammer, the hammer's kind of clear, it's a blunt object. What's going on with like your power saw? How does the saw work? We know it cuts wood, but like what's going on inside? I don't know if that's a good example, but all right, so this is annoying. Let's come up with something that replaces it. So what we're gonna do, I'm gonna come up here and we're gonna make a new class. And we're gonna call our class single linked list. Or singly linked list is how I. And what will we have in it? We're gonna have private. And all we really need to store here is the head pointer. And head pointer is gonna point to a node. Let's just call it head.
Is this going to be the same? Is this going to be some? Is it going to be something completely different to what we were just doing, or is it?
We're going to use nodes as part of it. And we're gonna expedite this process for adding new nodes and deleting new nodes. So let's make a little note of what we're doing here. We need constructors. We need accessor methods. And we need a destructor. You know what? This is a really long name. Why don't we just shorten this to SL list? How do you guys feel about that?
So the private's calling upon the class node.
Private is it's gonna have one object. It's the head, a pointer to a head node. Storing a pointer. SL list stands for singly linked list. So we should have what kind of accessors do we need? We need set head, get head. Set head will be not returning anything, but it should take in. Probably shouldn't take in the pointer, but maybe it can take in the argument for it. And get head should return a pointer. We'll decide in a little bit if that's how we want to set up those two right there. constructor, we can do one that's got nothing. And maybe one that takes in an item, the first item. And remember, when we have a destructor, it starts with the tilde. So those are going to be our prototypes for now. We'll decide if we want more or not later.
Constructors in the top.
Yeah, those are going to be our constructor. This is like a default one.
Get started by having experience in it.
No, because one takes in nothing and one takes in an item. So if you don't pass it anything when you do it, it's going to go with the top one. And when you do
Okay.
pass something to it, it's going to do the bottom one. Just like class node had 3 constructors here. Oh, I don't like the way that looks. I'm going to come up here and change that so that it's descriptive.
Question here.
What's up, Irving?
Did we get rid of any of the code from the top, the other class node?
No, this is, we're looking at class node right now. We're going to use class node as like, what we're kind of doing is SL list is like building a train and node is the car. Or if it helps you, this is building a book and each one of these is a page. So we need this node. We're not doing inheritance, although one is exclusively made up of the other. It's not based on inheritance. It's just an interacting of 2 different objects. So we're keeping the other one. It's still there. So we're probably gonna use this set next pointer, get next pointer, set item, get item, while we're building stuff. So we got these things. Let's go down and build the the implementations. That's got the node implementation. You know what? We'll do it right here. Doesn't matter what order it's in down here. So this is, I don't need that to configure constructors here. This is our S singly linked list implementations. And we always got to do the name with the scope resolution operator. And I'm going to copy that block and put it in front of each one. All right, let's go in and modify them. Let's start with set head and get head, because then we can use those in making our constructor. So set head, we have access to a node pointer. So what is the thing? Let's see. We've got set item, get item, set next pointer, get next pointer. Set head is, we're doing the first one. We need to make takes in a node pointer. Let's think. No, we're setting head. And it's called head. So head equals a new node with whatever arg item is. That seem about right? So this is making a new node. Head is a pointer. And new makes a pointer,
This is making a new point for the new art item, which is what we're.
which is what we passed in.
In general, get something will now return head, right?
New node with nothing in it. We're not having anything in it.
Okay.
Okay, so now we come up here to our default constructor. And here we're not doing anything, so we're just going to do set head empty. Let's see. Now we gotta set it like that because we don't have a blank set head. And this one right here will look similar, but it'll be set head with arg item. So we've got two constructors right now. Both of them are setting the net node pointer, the head pointer. And we need a destructor here. For now, let's leave it as that. Or maybe when it's destroyed, maybe we can tell it to see out. But we'll come back to that. Well, we haven't done anything with this yet, so like, don't run it yet. It's not doing anything yet. All right, so let's come up here and we're basically wanting to redo, well, we don't need to do Mary, Bill, James. Let's do the one in singly linked list. Let's build this train. So I'm going to comment out all this shit. Commenting out all the hard coding. And let's comment out the memory management too. That should be part of the destructor. All right, so we got our singly linked list class. It's got a head. And we got head pointer right here. Do we even need that? Let's see. we're gonna say, let's override this, say head pointer equals new node. And we're gonna pass in AB. Get rid of that. I don't know that I need that. And if I need it, I can type it back up. And now we will make a, let's say, let's call it, this is SL list, my list. We are going to pass in, maybe we should have one that passes, have a constructor that passes in a pointer. Let's make a constructor that passes in a pointer. And I'll come down here and we'll build that. And all we're really doing is doing set head or head equals arg PTR. Okay. So now we can come up here and we can pass in head PTR. That's what we designed that for. Okay, so now we've got our singly list started. We need something, we need more accessors. We need something that allows us to modify this. We need to have something that adds to the list.
Can I look up your single link list again?
That,
I mean, like the actual function.
that.
Oh, okay, no, okay, thank you. Okay.
Let's go back to the camera and like talk about this for a second. So we got head PTR. And it's pointed at AB. And AB is currently pointed at null PTR. And then we made my list. The only thing it has in my list is head. And head points to AB right now. So we want to build, our goal is we need another item that populates this with CD and points that at null pointer. So like, we already use next. I don't want to use next because that's in the node class, and having using next might make me think of the node class. If this is the head of the train, then maybe we'll call this tail of the train.
So could we call them each like cart 1, cart 2, something like that?
Well, we don't actually need to name them. They don't need a name. We're going to start using new node as we build it. We don't want to make a bunch of nodes there and then do more lists that point to it. We're just going to make it all part of one sequence. But I like where you're going. I guess like it's engine and caboose, but that's long to type. Head and tail is pretty easy. So maybe let's make a set tail and get tail. And get tail is going to have a pointer to the tail. And we'll come down and we'll build that down below. Put that below our, if it's there, we got to do our scope resolution. So the set tail, what it needs to do, we only have information, only starts at the head of the train, right? It only starts at the head of the train. So we're going to need a node pointer. Let's use a node pointer called like, I don't know, temp or temp PTR. Temp's probably easier. I'm going to do PTR. Node temp pointer, and we'll just have it as that for now. We should probably like, if the list is empty versus the list is not empty. Because if the list is empty, head pointer's putting it null. So I don't really want to tell it to make it get head. So like, let's just say if head equals null PTR. Nope, if get head equals null PTR, then the list is empty. So what we're really doing is setting head equal to the new item. And then we can, if that's the case, we don't need tail anymore. That's already done. We've made the train. I'll do a return. Then if that's not the case, if head pointer exists like it does now, well, I'm going to start off with temp PTR. We're going to have it equal head pointer or get head. And then what I want to do pictorially is it like if I have a bunch of cars, I want it to jump to the last one. So temp pointer, temp is pointed right here and at head. And I want it to jump to the end so that I can add item. We can add an item here. So the way we can do this is we're going to check to see, like each of these has two pieces of information, right? It has an item and it has a next PTR. What's different about this final item is this final item points at null pointer, right? So that can be our condition on our loop. Let's make that our condition on our loop. Oh, I'm off screen. Let's just say null PTR right there. Let's make that our condition on our loop. We're going to go through a loop. And so what I need to do is on each step, I need to have it go jump to the next, make temp redirect to the next. So temp has to equal like get next. And the way that works on this, well, okay, we're gonna make a while loop. And we're gonna say while temp PTR get next PTR does not equal null pointer. That tells us we're not at the end of the train. We'll say temp PTR has to equal temp PTRs get next.
So one thing simply saying like, use until it's equal to no pointer.
Kinda.
So it's kind of how the.
It's-
Kind of, it's.
let's-
simply
let's-
recursion, right? Like calling upon itself again, again.
No, it's not recursion at all.
I know it's not.
It's jumping caps.
Then, you know, go like this and this and this, and redoing it again and again until we get to your second point, right?
It's kind of doing this thing. It's actually doing like what we did with our print thing, right? The print thing had a problem, whereas when it got to the end, it didn't actually like, let's figure out, there was an issue with what was going on at the end. So let's take a look at what we've got set up for our set tail thing here. When we get down to temp is pointed here, when temp is pointed, the final lap, temp PTR is pointed here. Well, when it's pointed here, get next was fine, so we moved. So temp pointer is pointed here. The final while loop is saying, is the next null thing null pointer? It is. So there's no issue on the setting this up. It looks like this gets us to the end of the train. And so head at the end of the train is at temp PTR. So what we're going to do is do temp PTR set next, or we need to make a new node. Temp PTR set next. You do new node. And we're gonna pass in arg item. That sets the item in the next cell. And makes it its pointer null.
But I am.
Okay. All right, let's go back up here. What do we have so far? Oh, you know what? We should actually be able to run it and have it show just AB. Because we got the print thing here. I'll comment this one out too. Let's just make sure our setup works. Some bitch. Why is this in a different window? Why is my output separated from?
Oh,
I-
yeah, that's the thing, I forgot.
Error list. Okay, what was wrong with it? Let's run it again. $143, get ahead. Ah! Scrub. What did I do? What the fuck was this? This should just return head. The hell was I doing there? I had constructor thing going on in my head.
I was so confused when I saw it, 'cause I was thinking, like, am I thinking this incorrectly? I was like contemplating life at that point, 'cause I was so confused, 'cause I was like, oh, I must have not understand what get ahead is supposed to do. I was like so confused.
Well, it told us that I fucked up, which is good. Get tail. I need to populate it too. It hasn't returned anything yet. What if I did this and I did everything but the final line? That got us to the end of the car, right? If I copied that, I don't want to do the set item thing. So if get head equals null pointer, we're gonna return null pointer. But maybe we should tell the dumbass that this is an empty list. And now we can do temp pointer, get head. This jumped us to the end of the train. And now get tail should be set up. Oh, no. Same issue. Return temp PTR. It's returning a pointer. All right, now can I run it without a problem? I should be able to get AB as a single list. Why did it pop back over to my other thing? That was weird. It ran. It's immediately, what's it doing? Goddamn zoom bar. It's just exiting. It's running just fine. There's just nothing to show at the end of the list. All right, let's close that. All right, so we had set tail. We just passed an item. Can I do that here real quickly? Just up here in the main. Say my list. Dot set head is CD. That works. I should be able to run it, and it's going to give us A, B, and CD. I hope that works. It did not do CD. So something's wrong with my set head thing. So let's come take a look at set head. Or sorry, did I say set head? Fuck, set tail. I heard it in my head. All right, trying set tail. Let's see if that worked. There, quit fucking hopping out. I don't like it hopping out right there. So we can go through how many different letters did it have? We went up to IJ. So this looks like it's going to be pretty easy to go through and just set tail. We'll do EF. And since I'm a lazy fuck, I'm going to copy and paste and just change the letters. And it printed our whole thing. Now, so now we've got everything working on adding to the train. We still got to work on the destructor. So what did we comment out for the destructor? What goes on in the destructor sequence? The destructor sequence was that current node pointer equals head pointer equals next, and delete current. So start at the head of the train and just keep deleting it. So we want our let me copy that as a block down to my destructor. I will comment it out. But that's kind of like what we want to simulate. I think we're going to start off with making sure it's not a null pointer. So steal a little information. If get head equals a null pointer, see out this list is an empty list, nothing to delete. And it doesn't have a return. So we'll just say return an empty in the program. Otherwise, this is where we got to enact this. So let's make a node pointer. Temp equals head PTR. Get head, sorry. So temp is at get head. That's what current node pointer is doing. Then we want to do a while loop. While the next thing is not a null pointer. Let's come up here and grab that loop rather than retyping it. I just wrote temp. I'll change this to temp PTR. That way I don't have to change a bunch of code there. This is the line that needs to change. So temp pointer is set to head pointer. We want head pointer. So we want to set head equal to temp pointer dot get next. I'm going to copy that. What is wrong with that? What did set head take in? Set head took in an argument, which means it should, maybe set head needs to take in a null pointer. Let's go back and edit set head. And we'll just say head equals arg PTR. And I gotta go up and top and change the constructor up top. Which means that changes this first thing right here too. No, that works. At PTR. We'll have to check our constructors in a second. I thought I'd change that on line 38. Did it not update it? Yeah, it's a silly program. I did update it. Okay. Oh, that's gotta be what changes. Shit. Set head equals new node. Arg item. That's in my set tail thing. Use another quotation or parentheses. That needs to be a new node also. Or set head in that thing. And that's got to be a new node, empty set. Oh, changing all that, using set head in this thing fucking changed everything, didn't it? Set head, that is doing this thing, head PTR equals head point PTR get next pointer. And then we got to delete the current pointer. The current pointer is temp pointer.
So like, is everything that, one, while 18, while, processing what, that's the next.
So it's doing this. Temp points to here. And it says, okay, we're gonna make head point to here. And now temp's pointing to here and head's pointing to here. And we're gonna delete head. Which means I need wood to continue the loop. To continue the loop, I actually need to point temp to head again. So let's set temp to get head again. And maybe we can have it do a C out. C out. Destroying item. Temp PTR. Get item. Let's see if that works. So it destroyed everything but IJ, which means just like the set tail loop, we have to add one more thing. So what's going on at the end? Head gets to here. That one gets axed, that one gets axed. Head set to here, temp is set to here. So we just need to delete head. And we'll set head to null pointer. Head token and pointer, so we can do that. Null pointer. And we'll set temp equal to head again, just so that everything is pointing at a null pointer. That's temp PTR. Let's go with get head. That should destroy the whole list. Did not. Oh, I did. Might have. I didn't do the C out one more time. There we go. So we've made a singly linked list. We've made it so we can add to the tail. And then we set up our destructor. I think we're looking at doubly linked lists on Wednesday. This is where, like right now, we can only go forward on the train. Or like backwards on. We can only start at the front of the train and go backwards. That's not how trains work. You can go back and forth. So we're gonna have a way that we go back to the previous node. That's called a doubly linked list. That's for Wednesday. Peace. Stop recording.